Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Here and now I will presentation about Bahasa Inggris Matematika. And before I'm presentation, let me introduce myself first. And my name is Durrotul Wafa. My ID student number is 22101182200022, and I am from group 5. And here I will explain about vocabulary video in chapter 2, example 7, 8, 9, and 10. At the first, I will explain about vocabulary. Yes, at the first is algebra, which means algebra. Algebra, it is the part of mathematics that helps represent problems or situations in the form of mathematical expression. In algebra, we use numbers like 2, -7, 0, 0.06, 8, etc., which have a definite or fixed value. In algebra, we use variables like x, y, and z along with numbers. Same use in algebra. Example, William had a few chocolates with him. Jack came across and took away 5 of his chocolates, and then he had just 7 chocolates remaining with him. How many chocolates did he have before Jack came to him? And we can write x minus 5 equals 7, and the left and right sides we can addition with 5. X minus 5 addition 5 equals 7 addition 5, and will be x equals 12. And the next is coefficient, which means coefficient. And a coefficient is an integer that is written along with a variable, or it is multiplied by the variable. In other words, a coefficient is the numerical factor of a term containing constant and variables. Example, in the term 2x, and 2 is the coefficient. The next is function, which means function in mathematics and expression, rule or law that defines a relationship between one variable, the independent variable, and another variable, the dependent variable. A function assigns exactly an output to each input of a specified type. It is often written as fx, where x is the input value. Example, fx equals x divided by 2. It is a function because each input 2x has a single output x divided by 2, and f2 equals 1 and f16 equals 8. The next is greater than, which means lebih besar dari. The greater than in maths is placed between two values in which the first number is greater than the second number. Example, 10 greater than 8. The next is greater than or equal to, which means lebih dari atau sama dengan. The greater than or equal to is used to represent inequality in math. It tells us that the given variable is either greater than or equal to a particular value. Example, a student is greater than or equal to 50. The next is less than, which means lebih kurang dari. The less than sign is one of the inequality signs which is used to compare the number. If the first number is less than the second number, less sign is used. For example, 5 less than 10. It means that the number 5 is less than the number 10. The next is term, which means suku. A term can be a number, a variable, product of two or more variables, or product of a number and a variable. An algebraic expression is formed by a single term or by a group of terms. Example, in the question 4x addition y. The two terms are for x and y. The next is factorization, which means factorisasi. In math, factorization is when you break a number down into smaller numbers that, multiplied together, give you that original number. When you split a number into its factor or divisors, that is factorization. Example, factorization of the number 12 might look like 3 times 4. The next is digit, which means angka. Digits are the single numbers used to represent values in math. 0, 1, 2, 8, 4, 5, 6, 7, 8, and 9 are used in different combination and repetition to represent all the values in math. Any of the 10 numbers from 0 to 9 can be represented by a symbol known as a digit. An example of a two-digit two still D, and number is 65. The next is at the last is number, which means bilangan. A number is an arithmetic value used to represent quantity. Hence, a number is a mathematical concept used to count, measure, and label. Thus, numbers form the basis of mathematics. For example, this is one butterfly and these are 4 butterflies. Yes, and the second I will explain about example on video. And the question is find x. Yes, in this 3x addition 5 equals 7. And the left and right side we can addition with negative 5 and will be 3x addition 5 minus 5 equals 17 minus 5 and will be 3x equals 12. And at the left and right side we can times with 1 divided by 3 and will be 3x times 1 divided by 3 equals 12 times 1 divided by 3 and will be x equals 4. The next is 7x minus 2 equal negative 10. Yes, and the left and right side we can addition this with 2 and will be 7x minus 2 addition 2 equals negative 10 addition 2 and will be 7x minus equals negative 8. And the left and right side we can times with 1 divided by 7 and will be 7x times 1 divided by 7 equal negative 8 times 1 divided by 7 and will be x equals negative 8 divided by 7. Yes, and the third I will explain about chapter 2 and example 7, 8, 9, and 10. At the first is example 7. Allison and Raquel were competing in a race. Allison had a 10-minute head start and was running at 3 km per hour. And Raquel ran at 5 km per hour. And in how many minutes did Raquel catch up with Allison? And the solution, the model for the problem is distance traveled by Allison equal distance traveled by Raquel. Since we are asked to find Raquel's time, we will represent it by t. Note that the unit of t must be hours, since the rates are given in hours. Allison ran 10 minutes more, which will be represented by t addition 1 divided by 6, because 10 divided by 60 will be 1 divided by 6. Since 10 minutes is 1/6 of an hour, and will be let t equal Raquel's time and t addition 1 divided by 6 equal Allison's time. And using this sense equals times time. and 3 times t addition 1 divided by 6 equals 5t. 3t addition 1 divided by 2 equals 5t, and 1 divided by 2 equals 2t. t equals 1 divided by 2 equals 1 divided by 4 hours, or t equals 15 minutes. To check, we compute the distance traveled by each girl using t equal 1 divided by 4 for a girl, and t equal 1 divided by 4 addition 1 divided by 6 equal 5 divided by 12 for Alexander. Girl's distance was 5 times 1 divided by 4 equal 1.25 kilometer, and Ellison traveled 3 times 5 divided by 12 equals 1.25 kilometer as well. Note that we could have converted the rates to kilometers per minute by divide each rate by 60. This would allow t to represent minutes, and we could use 10 minutes in the equation instead of 1 divided by 6 hour, and 3 divided by 60 times t addition 10 equal 5 divided by 60t, and will be 3t divided by 60 addition 30 divided by 60 equal 5t divided by 60, and will be 3t addition 30 equals 5t, and 30 equals 2t, and t equals 15. The relationship used in this problem can be rewritten to express the rate as a question. Write equal distance traveled divided by time. Yes, the next is example 8. If Joy can find 5 rooms in 8 hours and Samantha can find 3 rooms in 6 hours, how long will it take them to find 7 rooms working together? And the solution, using the rate formula, and we see that Joy's rate of work 5 divided by 8 rooms per hour, and Samantha's rate of work is 1 divided by 2 rooms per hour. And let t equals the time to complete the job together, and the model is total number of rooms spent equal room spent by Joy addition room spent by Samantha, and 7 equal 5 divided by 8t addition 1 divided by 2t. 7 equal 5 addition 4 divided by 8t, and 7 equal 9 divided by 8t. 56 equal 90, and t equal 56 divided by 9, and t equals 6, and 1 divided by 2t. And next is example 9, and the question is, it takes Susan 10 hours long than Laurier to take their stories inventory. If it takes 3 and 3 divided by 4 hours for them to do the job together, how long would it take Susan to do it alone? And the solution, since Laurier take less time to complete the job, and we will let her time be represented by t. If we can find this time, then the answer to our problem will be t addition 10. The numbers of jobs considered in this problem is 1. Therefore, Laurier's right is 1 divided by t, and Susan's right is 1 divided by t addition 10. The model for the problem is 1 job equal amount done by Susan addition amount done by Laurier. Using 15 divided by 4 for 3 and 3 divided by 4, the amount done by Susan is 1 divided by 3 addition 10 times 15 addition divided by 4. 15 divided by 4, and the amount done by Laurier is 1 divided by t times 15 divided by 4. Substituting in the preceding model, and 1 equals 1 divided by t addition 10 times 15 divided by 4 addition 1 divided by t times 15 addition time 15 divided by 4 and equal 15 divided by 4 times 1 divided by t addition 10 addition 1 divided by t and will be 1 divided by 15 divided by 4 equal 1 divided by t addition 10 addition 1 divided by t. And simple the fraction of the left-digit the fractional equation 4 divided by 15 equal 1 divided by t addition 10 addition 1 divided by t, and 40 times t addition 10 equal 15t addition 15 times t addition 10, and 4 square t addition 40t addition equals 30 t addition 150, and 4 square t addition 10t minus 150 equals 0, and 2 square t addition 5t minus 75 equals 0, and will be because this is will be 2t addition 15 times t minus 5. This is equals this, and will be 2t addition 15 equals 0, or t minus 5 equal 0, and t equals negative 7, or t equals 5. Sign the problem request bicycle time. We reject the negative answer, and we see that t equals 5 is Lauria's time. Therefore, Susan can complete the job is 15 hours working alone. Yes, and the last is example 10, and the question: at the chocolate factory, Joanne's job is to experiment with mixing different amounts of milk and chocolates to find different flavors. If he mixes 2 quarts of type A, which contain 15% chocolate, with 1 quart type, which contain 10% chocolate, he creates type C. What percent of type C is chocolate? And the answer: in this situation, the red is the percentage of chocolates. For each type, we have the relationship amount of chocolate in the type equal percent of chocolate times amount of the type, and amount of chocolate in type A equals 0.15 times 2 equal 0.3 quarts of chocolate. Amount of chocolate in type B equals 0.10 times 1 equals 0.1 quart of chocolate. To find the total amount of the chocolate in the mixture, we add the chocolate quantities from types A and B. Total amount of chocolate in the mixture equals 0.3 quarts addition 0.1 quarts equals 0.4 quarts. Next, we need to determine the total volume of the mixture, which is obtained by adding the volumes of types A and B. And total volumes of the mixture equals 2 quarts addition 1 quarts equals 3 quarts. To find the percentage of chocolates in type C, we divide the total amount of chocolate by the total volume of the mixture and multiply by 100. And percentage of chocolate in type C equals 0.4 quarts divided by 0.3 quarts. And times with 100 equals 13.3 33%. Therefore, type C contains approximately is 13.33% chocolates. Yes, and the last, thank you, and thank you for the attention, and wassalamualaikum warahmatullahi wabarakatuh.